All right. So I hope that you have given a try at it. It's quite simple thing actually. All these things that we discussed. All these things we discussed in previous lecture. My computer is stuck again. Oh, okay. So why? Sorry, just 1 second. Yeah, now okay. It's better now. Okay, so I'm guessing that you have given a try at it, and then you actually solved many questions. But still, I will go through one by one, and I hope that those who have not finished any of those can get some answer. First of all, the test question, and then at the end of the like all other tutorial, at the end of the previous year questions are given. So those things usually is very much similar to these self-testing questions. So if we understand the self-testing question, it is easier for us, or we can actually solve those questions. So first question, it says that in which reaction is water acting as a Bronsted-Lowry acid base? Yes, last Monday we discussed about the acid and base, and then we showed that acid, what is the attributes, not I mean properties of an acid, and what is the base. Another thing is there are many ways that we can describe or define an acid, right? Especially there are depends on the different type of scientists. They came up and then they describe acid according to the what best suits for them. But there are standards all over the world that according to Arrhenius, acid is what proton giver or hydrogen ion giver, and base is what hydroxyl ion taker. All right, acid will always donate proton, base will take hydroxyl. But Bronsted and Lowry, they came and they said, okay, no, why hydroxyl? When somebody is giving proton is an acid, who takes hydrogen ion or proton is an base, is simple, right? Why you are going to another thing again? Just proton, you stick to proton. So Bronsted Lowry, he says that acid is what it donates proton, right? And base is what it accepts proton. So this is acid and base. Now, according to Bronsted-Lowry, who water is donating proton, accepting proton, where water is accepting proton. For A, we see that here H2O, it becomes H3O and it becomes positive. So water actually took one hydrogen or proton from HCl. So this is the correct answer. What about B? B, yeah, it becomes the same thing, but it just joined and it produced a compound, and itself it becomes an acid. So it is not accepting one hydrogen or proton in that case, but later on it will donate a proton. Different case, that one. For C, hydrogen, this water is donating one proton to ammonia and it is become ammonium ion. So it is a acid, it is not a base. Same goes for D and B are the same thing. So yeah. So A is the correct answer for this case. Question number 2 says that in which of the following reactions is the first reactant acting as an acid? The first reactant. Which is the first reactant? This one, this one, this one, and this one. So which you are on the, and this is 1 and this is 2, right? And they are reacting together, and that's why plus in between. So 1 and 2 reacting together. So this is the first one that is reacting. This is the second one is reacting. Question is asking first one reacting as an acid. Which one is acting as an acid? Which one is donating proton? Right? Here it does not say whether it's according to Bronsted-Lowry or Arrhenius, but according to our understanding, we will just stick to the Bronsted-Lowry thing, not Arrhenius one, okay? Because Bronsted-Lowry, it accepts or it covers the wide range of acid and base. Arrhenius, not always we can find what is the base one. So here the first one is HPO4. This is a biphosphate ion actually. And from here we see that at the end, after the reaction, the phosphate ion is left over and the hydrogen gone already to water, right? So it is an acid. It is acting an acid. What is for the second one? What is for the second one? That biphosphate ion, the same thing as in A and B. The first reactant is the same thing. The second reactant is water and nitric acid. All right, water and nitric acid. So for the second one, we see that biphosphate ion, it does not donate or it does not give away the hydrogen. Rather, it is taking one hydrogen from this nitric acid. And by taking, it becomes H2PO4. See, it becomes H2 and then this nitric acid is giving hydrogen and becomes nitrate ion. So it is not a base. I mean, it is not an acid. Of course, it is not an acid because it cannot give. That's why it is not an acid, it is the base. For C, same thing is going on. And here it is taking one hydrogen from water and becoming H2CO3 and so on. So now, I mean, this is the correct answer. A is the correct answer. But just since we are here, just let me say one thing to you, that this A and B is the same thing, right? The first reactant is the same thing, the same species, HPO4, the same species. Here it is H2O and here it is HNO3. This is the different thing. First one, first case, it is donating the proton to water, and second case, it is accepting the proton. Yeah, so does it contradict? Is it the wrong thing? No, because for one, option A, water is more basic than HPO4. HPO4 is acting as an acid here, right? Is acting. It is, last lecture we have seen the water can be acid or base, right? We have seen that water acts an acid and base both. But for this case, water is working or acting as a base by taking one proton. But for B, HPO4 is weaker. It is not very strong acid, but is stronger than water. And that is why when water is there, it is acting as an acid. But when nitric acid is there, nitric acid is more stronger than HPO4. And that is why HPO4 is taking one hydrogen from nitric acid. Right? So this is the difference. This is the difference for the same species, depends on what type. And it will be this information, just remember, not specifically for this case, but similar case will be required for buffer. When we study buffer, it will be helpful for us. Question number 3 says that 1 molar standard solution of sodium hydroxide is used to analyze the concentration of hydrochloric acid in brick cleaner. The sodium hydroxide is called a standard solution because we have seen the standard solution, because the sodium hydroxide is a good primary standard. No, it is not. Sodium hydroxide is not good primary standard because it reacts with the ambient air or the air, it reacts. But for this case, it says that a 1 molar standard solution, right? 1 molar standard solution. That means it is telling us that it is 1 molar, the concentration of sodium hydroxide. So that means we know the concentration of the solution accurately, and that is why it is a standard solution. Even the concentration of the solution is 1 molar, right? The number 3 option, it is not correct because it can tell you that the concentration of 1 molar, but in case if it is not a 1 molar, then it is not a standard. But if we know that this is exactly 1.00 molar, then it is a standard, or it does not have to be 1.001 molar. It have to be a concentration that is accurately known to us. It can be 1.02 or 0.99 or 1.10, whatever the concentration must be known precisely, that we are very confident that is the concentration. Then it is a standard solution. Since you're here, it is said that 1.00 molar, right? So when it says the 1.00 molar, it means that we are very much confident that this solution is the value of this solution is correct until the 2 decimal point. That means even if there is a 0.01 changes, I will know. I will mention it. It is not even it is not even 1.01. It is exactly 1.00. But beyond this, we do not know. 1.00. It can be 1.009. It can be 1.007, 1.005, whatever it can be. But until this range, we are sure that it is 1.00. Beyond 00, we do not know. So until 2 decimal places, we are very sure. So that is called the significant figure. That is the thing of the significant figure actually. We are very much sure of this until this space, up till this position. Okay. And question number 4, sorry. Sorry, that the properties of primary standard solution standard for use in acid-base titration include all of them below except, that means all of them are primary standard but except something. Primary standard, it should be high molar mass and it should be inexpensive. Yeah, it is true, we know. High purity and have a known formula. Yes, this is also true. To be a primary standard, it must be like that. High stability and it is not delinquence. That means it is stable at any time, and delinquence means it does not get the water from environment or air and becomes watery. It should not be like that. Yes, this is true. But if it is a high reactivity with oxygen and low solubility in water, it cannot be a primary standard. Like if it is a very reactive with the oxygen in the air, that means you cannot keep it for any purpose, any time. You keep it for half an hour, 30 minutes, and it changes. Its concentration changes, so it cannot be a primary standard. So D is not the desired property, so it is the correct answer for this question. Question number 5, which of the following is not suitable to be used as a primary standard? Potassium hydrogen thalate, yes. Oxalic acid, yes. Sodium borate, yes. But sulfuric acid, no, because it is delinquent, or it takes the water from environment, or it absorbs the water, and that is why sulfuric acid in industrial cases is used for desiccating, for removing moisture, for many chemicals in the chemical industrial level, not in the household, in the industrial level. Question number 6, it says that calculate the mass of sodium chloride present in 500 milliliter of 0.2 molar solution. So N equals C into V, right? Who doesn't know that? You don't have to tell me who doesn't know, but if you have any problem understanding this equation or this thing, please let me know so we can discuss. But this is the formula that N equals C into V. Number of moles is concentration times volume. All right. So if we know want to know the mass, we should know the number of moles. If we know the number of moles, and if we multiply it with the molar mass, we will get the mass of the thing. So 500 milliliter and 0.02, 0.2 times 500 milliliter means we have to convert it to liter, of course, and 0.5 liter. 500 milliliter means half of a liter, right? So this is the number of moles, and from that we multiply with the sodium chloride. Molecular mass of sodium chloride is, how do you find it? Sodium is 23, I'm just rounding up. Sodium 23 and chlorine is 35.5. So 35.5, so 58.5, right? If we multiply with 58.5, we will find what is the mass. I'm not sure. It should be given there. You can calculate later. Question number 7, it says that when 2.37 gram of zinc nitrate is dissolved in enough water to make 0.5 liter of solution, the concentration of ions in the solution are. There are 2 steps we have to solve this problem. First of all, it says that 2.37 gram of zinc nitrate is dissolved in enough water to make 0.5 liter solution. Okay, so 0.5 liter of solution, 2.37 gram of zinc nitrate. All right, zinc nitrate and 0.5 gram. Now, can you tell me, anyone, that does the gram matter here? I mean, no, not. It's not a correct question. The question should be that in a chemical calculation, I mean chemical equation, what is the most important thing that we should look into first? Anyone want to chip in? Let me check in the chat. Anyone? Anything in the chat? C is for Bronsted-Lowry acid. Okay, I think we discussed already. Anyone want to chip in? Okay. So the most important thing is, I'm sure that you know, but if you even know, or if you do not know, I will always tell that this 1 mole, right? 1 mole of zinc nitrate is producing 1 mole of zinc and 2 moles of nitrate. That means if we break this zinc nitrate, like you have a hammer and you hit it, it is broken. So it's broken, you will find zinc and nitrate both. You can ask me that why we don't find out zinc and nitrogen and oxygen. That is a similar, I mean, different questions. But to be in a brief, that zinc and nitrate are 2 different looking and 2 different type of species. They are staying together in the compound. If you break the nitrate, then only you get nitrogen or oxygen. Okay, but if you break zinc nitrate, you get zinc and nitrate first. So if we break, you will get 1 zinc and 2 nitrate because of the 2 here. Right? It means in 1 compound, 1 zinc and 2 nitrate is there. how it is there. We have some time to spare, so we can. It is zinc, and one side is 1 nitrate, NO3. Another side is another nitrate is attached. So this is why zinc nitrate, and when we write in short form, we just write and multiply by 2. The small 2 means only nitrogen and oxygen. The nitrate is 2, right? So this is actually in the compound. No, it is not in the compound. In the compound, zinc will be like this. And then the nitrogen is here, and then oxygen is also there on every nitrate. Nitrogen will have 1 oxygen to each, something like that, okay? And it is not simple, it is a bit complicated, but to be simply we can put in this way. That zinc nitrate means 2 zinc, 2 nitrate, 1 zinc. Okay. Now, if we break 1, I will get 2 nitrate. And the question is asking not even the number of moles, but the concentration of ions. What will be the concentration of ion? Right. First of all, what we'll do is we'll find the number of moles, because concentration means number of moles over volume is equal to C, right? Concentration is N over V. So, yeah. So 2.37 gram of zinc nitrate means how many moles of zinc nitrate? Can anybody tell me how many moles of zinc nitrate? How do we find it? We just divide 2.37 by the zinc nitrate, molar mass of zinc nitrate, all right? And the molar mass of zinc nitrate is, we have to find out, zinc is 65.39 and nitrogen is 14. There are 3 oxygen is there, each is 16. So times 3, and then this one will be multiplied by 3 as well. So altogether, I do not know how many. 63.5 plus nitrogen, 2 nitrogen 28, let's say, and 16 times 6, because 187. So 2.87 yeah, 8, yeah, over 187.5. So we will get 2.87 by 187.5, 0.15, is it? 0.015. Yeah, anybody wants to say something? Is it?
Sir, it's 2.37.
Yeah.
You wrote 2.87.
Oh, okay, that's why. Sorry, thank you. So 2.37 over 187.5. So 0.12, yeah, 125, something like that. 0.126 actually. Yeah, 126. Now 0.126 for the number of moles of zinc nitrate. We have this number of moles. How many moles of zinc will be there? Number of moles of zinc will be there. Can anyone tell me how many number of moles of zinc will be there? Same, right? Because it is 1:1. 1 mole of zinc nitrate, if broken down, 1 mole of zinc I will get. If X mole we break down, I will get X mole. If I break Y mole, I will get Y mole. Whatever, it will be the exactly same thing. Understand? I don't know whether you understand. So let me write it again. So if let's say 5 moles of zinc nitrate, there will be 5 mole of zinc. If 10 moles, I will get 10 moles of zinc nitrate. 15, 20, 100, 1000 million, exactly same number of zinc I will get. But since it is 2 here, I will get double of what is broken from here. If 5, then I'll get 10. If 10, I will get 20. Just double because of the 2 in front. Okay, so the constant, it is asking us for the concentration. So 0.126 moles, and it is in 0.5 liter. 0.5 liter. So divided by 0.5, and it becomes 0.02, 0.025. All right, 0.025 mole per liter or molar of zinc. Zinc is this. How about nitrate? Just the double of it, 0.05. All right, so so C is the correct answer for this. All right, everybody okay with this? Okay, moving to question number 8. A solution was prepared by pipetting 5 milliliter of 18 molar sulfuric acid, H2SO4 is the sulfuric acid, to a 500 milliliter volumetric flask and top up to the mark with deionized water. What is the concentration of sulfuric acid in the solution? Again, it is concentration, not the number of moles. Yeah, concentration is C equal N over V. So I think you better, those who are having some problem, or if you are having some not very smooth understanding, please go and check with the equation N equals C into V, or the gas law, right? How to produce the solution, number of moles, what is the number of moles, what is the Avogadro's number, and if you want to consult with me anything on any of those, please let me know so that I can find a time for you. Okay, so a solution was prepared by pipetting 5 milliliter of 18 molar sulfuric acid to 500 molar milliliter volumetric flask and top up to the markup with iodine. What is the concentration of sulfuric acid in the new solution? In the solution means when it was from 5 milliliter, it goes to 500 milliliter. What will be the new concentration? We can do it in a long way and short way. The shortest way is that N1 V1 N2 V2, right? We have seen, I think you have seen this equation in high school, N2 V2. So for N1 is 5 milliliter, is it is V1. 5 milliliter is V1, 18 molar is N1, 500 milliliter is V2. So what will be the number of N, right? So if we do in this way, and then if we just divide by the volume, I will get the N for the new concentration. And then from there, using the 500 milliliter, I can find the concentration easily. So 5 times 18 over 500 milliliter. So in this way, I will get, I don't know, let me check. 5 times 18, this one by 500 is 0.18. 0.18. All right. So 0.18 number of moles. N2 is 0.18. And 0.18 is in 500 milliliter. So it is 0.5, 0.36, the concentration of the solution. But What is the concentration? Number of moles. I think there is a here it is moles per liter. There is a problem with this question. It should be 0.36, yeah, 0.36 molar. This is which is not in here. 0.36 molar, the concentration of this. So none of this is correct here.
Sir.
This, yeah.
I think it's 0.18 because it got diluted.
Wait. A solution was prepared by pipetting 5 milliliter of 18 molar sulfuric acid to 500 milliliter volumetric flask and top up to the mark. What is the concentration of sulfuric acid in the solution? Okay, 5 milliliter is, we are considering V1 is 5 milliliter. So this is, where is the V1? 5 milliliter, and then 18 molar is moles per liter. Moles per liter, and then 500 milliliter. 500 milliliter. Okay, so now this one 5 milliliter gone, and then moles per liter remains, right? So it should be C, 0.18 moles per liter. If we just consider the equation only, and then we do not consider the units, there are most of the time you will find that it is problematic for you to construct the idea from it or find out to make the meaning of it. So if it were moles, only 18 moles, then it would be 0.36 molar. All right, 0.36 molar. But since it is in molarity, or it is in concentration, is given already, so 0.18 remains. So thank you for who, I don't know, who was it?
Lynn.
Lynn, thank you. Thank you very much. But I think, yeah, Lynn spoke out. And I'm sure that many of you had the same confusion, right? But you didn't. So Lynn, all that applause in going to Lynn. But anyway, that you find out the problem, or you found out the not mistake actually, the to clear your confusion. That is good. Question number 9, the same thing actually. When 50 milliliter of nitric acid HNO3 solution is exactly neutralized by 150 milliliter of 0.5 molar solution of potassium hydroxide, what is the concentration of nitric acid? Right now, there is exactly the same thing like 8, but little twist here, that it is asking me that there was a reaction first, and only after that we have to find out what is the changes after the reaction. So what should we do? 50 milliliter of nitric acid neutralized, exactly neutralized, that means at the same point, by 150 milliliter of the solution of potassium hydroxide. What should we do the first one? Can anybody tell me what should I do the first one? The first thing I should do? What should I do? The first thing, what should I consider?
Find the number of moles.
Yeah. Find the number of moles. So to find the number of moles, what do I have to do?
N equals to CV.
That is the second step. Before that, how do I find the number of moles, right? From what step should I can get the number of moles? From what step? Anyone? Anyone?
Balance
No,
equation.
exactly. Thank you. So yeah, somebody else. Brian also said the same thing. Yes. Write the equation and then balance it. So HNO3 and potassium hydroxide. Can anybody tell me which one is acid and which one is base here? One or two? Which one? Which one is base? One or two? This is one, this is two.
Two.
Good, thank you. Right. So, where is it? Okay, so potassium hydroxide is base, right? And now nitric acid is the acid. Of course, we know nitric acid. The reaction, what will happen is potassium nitrate and water. So what we said last lecture, that when acid and base react, there will be always water. Water is constant product. And then there will be another salt. This is a salt, depends on what type of acid or base you are using. Now, the thing is, so is the reaction balanced?
Yes.
Yes, the reaction is balanced. The 1:1 reaction, right? Now we have to find out this number of moles. First of all, we have to balance, or we have to write the equation rather. We have to write the equation, balance the equation first. Only then we will be able to find out what is the number of moles required. This 1:1 reaction, so it says that 50 milliliter of nitric acid, 50 milliliter of nitric acid, and then was neutralized by 150 milliliter of 0.5 molar solution, 150 milliliter and 0.5 molar moles per liter of solution. So how many number of moles in potassium hydroxide in this? How many moles do you find it? N equals C into V, right? N equals C into V. So C is concentration, and that is moles per 0.5 mole per liter. Moles per liter. And V is 150 milliliter. I have to convert it to liter because this is moles per liter and it is in milliliter. So I have to convert either one. So it's better that I convert 150, but by 1000, 0.15. 0.15 times 0.5. So 0.075. Number of moles, 0.075 of potassium hydroxide. So how many moles of nitric acid will be there? Can you tell me? Looking at this. The nitric acid will be the same, right? Number of moles will be the same because it is 1:1 reaction. If I need 1 mole of potassium hydroxide, I would need 1 mole of nitric acid. If I needed 10 more moles of potassium hydroxide, I would need 10 as well, nitric acid also. If I need X mole of potassium hydroxide to neutralize the nitric acid, I will have exactly X mole. So since it is 1:2, this is the goodness or good thing about the 1:1 reaction, exact same, or rather all the equations. It is the key thing that we should be looking at too. So nitric acid should also have 0.075 number of moles, and this number of moles is in 50 milliliter. It is in 50 milliliter. The 50 milliliter solution was used or exactly neutralized. That means it was only 50 milliliter of nitric acid was used, right? 50 milliliter of nitric acid was used to neutralize this amount 150 milliliter of potassium hydroxide. So in 50 milliliter, there was enough number of moles as in 150 milliliter of potassium hydroxide solution. Right. So how many number of moles? It is 0.075 number of moles of potassium, number of moles of nitric acid, and it is in 50 milliliter. So it will be, we will divide by 50 milliliter, but 50 milliliter we have to convert it to liter as well. So 50 times 1000, and then you divide it. So 1.5 molar it will be. So 50 divided by 1000 to convert it to liter, and then it is giving 1.5 molar moles per liter. So C is the correct answer. Question number 10. A 10 milliliter sample of vinegar containing ethanoic acid is made up to the mark with water in 250 milliliter volumetric flask. 20 milliliter liquid are then titrated against 200.2 molar sodium hydroxide. The average titer is 50 milliliter. The reaction equation is this. Exactly same thing, 1:1 reaction, right? 1:1 reaction, no problem. Exactly similar thing as the 9, but only the thing is here it says that a 10 milliliter vinegar solution containing ethanoic acid, or this is the ethanoic acid, or acetic acid. Sometimes we also call it acetic acid. It was top up to the mark of 250 milliliters. So let's say that this is a volumetric flask. Okay, so this is a volumetric flask. So what we do is I put 10 milliliter here. This is not a good one. I'll draw. Okay, so 10 milliliter I put inside first, and then I add another 250 milliliter of water. So what happened actually? I dilute, right? So 10 milliliter got diluted, isn't it? 10 milliliter got diluted. So how many times it got diluted? 250 over 10. 25 times it got diluted. 25 times it got diluted, right, in this conical volumetric flask. And then when it becomes, let's say this is the 200 mark, this 200 mark, after I dilute it, I take 10 milliliter of it, and then I go to do the titration or the reaction with sodium hydroxide. And the sodium hydroxide, the average titer when it comes to the, when it is average titer is coming, so that means I have done 1, 2, 3, like 3 or 4 titration or test repeating, and the average of those are 15 milliliter. And the sodium hydroxide concentration was 0.2 milliliter, 0.2 molar sodium hydroxide, right? 15 milliliter of 0.2 molar sodium hydroxide means, what is the number of moles of sodium hydroxide then? 15 milliliter times 2 molar, 0.2 times 15 over 1000. 0.03. Number of moles is 0.003, sorry. 0.003. So again, the same thing that in this 2 milliliter alucot means all the solution, the 10 milliliter of the liquid solution that is taken. We took it exactly has 0.003 number of moles of acetic acid as well, right? 0.003, isn't it? Let me check again. 20.2 molar, 0.2 times 15 milliliter over 1000. Yeah, 0.003 number of moles. So it is the same. This is the same because it is 1:1 reaction. Right, 1:1 reaction. So the number of moles will be the same in this 20 milliliter of acetic acid, 20 milliliter acetic acid. So 0.003 by 20 milliliter means 20 over 1000 in liter, and we understand that it is a 0.15. Concentration of 20 milliliter is 0.15 molar, right? It is 0.15 molar, we understand. But again, the thing is, it says that originally it was 10 milliliter, then it was diluted 25 times, and then this 20 milliliter is actually from this 25 times diluted thing. So 0.15, I have to multiply with this dilution factor to know the original concentration, 25. So times 25 means 3.75. So this is the correct answer. All right.
Sir,
Yep.
can you explain one more time that the 20 milliliter with the 0.15 molar? I didn't understand that.
Okay. So this 10 milliliter, right? The 10 milliliter sample of vinegar, I took it and I diluted it. I put it in this in here, and then I diluted it to 250 milliliter, which is 25 times dilution. Is this okay?
Yes.
Okay. So now this is not 10 milliliter anymore. This is not the same thing. This is not 10 milliliter sample. This is not. This is a 250 milliliter sample. This one, right? Which is diluted one. 10 milliliter was the concentrated one. And now it is diluted. All right. Now it is diluted. So this diluted thing, this 20 milliliter, we actually took from this diluted solution. This 20, after I make it 250 milliliter, then I use the pipette to take from here, all right, take from here to this 20 milliliter. I took the 20 milliliter from here. So this 20 milliliter is not the same concentration as 10 milliliter. 10 milliliter is no more. It has already got diluted. All right. So the diluted one, the 20 milliliter I took is from this diluted one. Now I am using this diluted 20 milliliter of this solution to react with sodium hydroxide. I am using this diluted portion of this aliquot of the solution, the diluted solution, 20 milliliter from this, I took it for further reaction with sodium hydroxide. So when I'm doing the reaction with sodium hydroxide, as I said earlier, that is a 1:1 reaction. Like 1 molar of sodium hydroxide will react with 1 molar of acetic acid. So 1 molar sodium hydroxide is reacting with 1 molar of acetic acid. Okay, let me delete first. Erase actually, not delete, erase first. All right, so this one, this 20 milliliter I took is actually from this diluted portion. And then I'm taking this 20 milliliter here and I am using this sodium hydroxide to react this diluted portion. Now it is 1:1 reaction, right? If I use X mole of sodium hydroxide, then I will know that, okay, if I need X mole of sodium hydroxide, that means I have X mole of acetic acid there, or ethanoic acid, right? Undiluted vinegar. So it doesn't say anything. Ethanoic acid. It says ethanoic acid here, so we just stick to ethanoic acid. It's 1:1 reaction. So 1 molar of sodium hydroxide will react with 1 molar of ethanoic acid. 5 molar, 5 molars, X molar will X molar. So I just need to, if I am, the clever way is if I can just know the sodium hydroxide number of moles, I will automatically know the number of moles of acetic acid or ethanoic acid, sorry, for this case. So that is why I use the same tactic, N equals C into V, to find out the number of moles of sodium hydroxide. It is 0.2 molar and it is in 15 milliliter of solution. So number of moles I find N equals C into V, C into V, and from there I find 0.003 moles of sodium hydroxide. Okay. Now, if sodium hydroxide is 0.003 mole, let's say that it is X. Is X. So it should be X as well. Acetic acid should be X as well. So acetic acid should be 0.003 moles as well. Right? Is this okay?
Yes.
Okay. So this number of moles we found, but this number of moles, like sodium hydroxide was in 15 milliliter. Here, unlike sodium hydroxide, this aliquot or 2-kit was in 20 milliliter. So this 0.003 mole number of moles will be in 20 milliliter of the aliquot. Right? Because this 20 milliliter we took of this ethanoic acid, the 20 milliliter of ethanoic acid, it is actually in this 20 milliliter, it is 0.003 moles. 20 milliliter, it is in the number of moles is 0.003 number of moles, same thing. So if it is in 20 milliliter, 0.003 moles, we can find the concentration easily. How do you find concentration? We just divide number of moles over volume, because C equal to N over V. So 0.003 over 20 milliliter means 0.02 molar liter. So if we divide, divide this way, we will find 0.15. Number of moles is concentration, sorry, molar, moles per liter. But this moles per liter, what we are doing is in this 20 milliliter concentration. 0.003 was the number of moles and 0.15 is the molarity, the concentration. Two are different things. One is the number of moles, one is the concentration. So both we find. The concentration we also find, it is 0.15 molar concentration. But this 20 milliliter was taken actually after we have diluted it to 25 times. So if we diluted this to 25 times, then what is in the original concentration, undiluted one. We have to, of course, we have to multiply to find out like how much was this in solution. Right. So that is why it was multiplied by 25 times, and the answer is 3.75. All right. Is this clear? Okay now?
Yes, clear. Thank you.
Okay. Brian may ask why the average titration for vinegar is the same for sodium hydroxide. Why the average titration for vinegar is the same for sodium hydroxide? Can you please stop? I don't understand actually.
Can I
Yeah.
ask like what the average titration for the vinegar is same with sodium hydroxide?
Is it same where?
Then
Question
because
number.
like you use the average the average titer is 15 millimeter and you times it with sodium hydroxide. Why is it the same咧? I thought the average titer is for the ethanoic acid.
I mean, your question is why I am taking 15 milliliter to divide to get the number of moles? One second. Your question. One second. You just ask your question. What is your question? Just ask.
Yeah, I forgot what I wanted to ask.
You say that I asked why why the average titration for vinegar is the same for sodium hydroxide. No, it's not same. It's 10 milliliter here, then 20 milliliter here, then 15 milliliter here. But I don't understand what is your question.
Never mind. Most probably I'm confused. sorry.
Are you talking about question number 10 or question number 11?
Question number 10.
10. Okay, once again, let me delete it. All those things is messy, and then maybe I can talk very quickly. Okay, so this question is asking or saying that 10 milliliter of sample of vinegar, which is ethanoic acid, this is ethanoic acid or acetic acid. It was taken in a volumetric flask and it was made to 250 milliliter. All right, so this is the volumetric flask and it was made 250 milliliter. All right. So 250 milliliter, 10 milliliter, like if you take Ribena, 1 spoon of Ribena, and then you dissolve in your mug, what is happening? Actually, you are diluting, isn't it? I'm asking not one, but I am asking everyone that you are diluting the 1 tablespoon of Ribena to your mug, and it becomes diluted. So it is not sweet that more. I mean, not that much sweet anymore, right? Because it is getting diluted. So how many times you are getting diluted? You are making it diluted. For this case, 10 milliliter, you are making 250 milliliter. So it is 215 over 10. That is 25 times dilution you're doing. Okay, this is one thing. After that diluted thing, 25 times diluted thing, out of this diluted 20 milliliter of that, 20 milliliter of the ethanoic acid actually. 20 aliquot means it is not the sodium hydroxide, it is 20 milliliter of the diluted solution, that means the vinegar. 20 milliliter of the vinegar, not the sodium hydroxide. You are taking 20 milliliter of vinegar, diluted vinegar. Let me write it here. 20 milliliter of diluted vinegar, 20 milliliter of this you are taking, and 15 milliliter of this. All right, 15 milliliter of this. It requires 15 milliliter of sodium hydroxide to neutralize, and then 0.2 molar of sodium hydroxide was used to neutralize this. All right, so you see that this is not the same number of, milliliter, it's different milliliter.
So may I ask
So-
how you get the 15? Sorry for interrupting.
No problem. You're okay. Here it is 15 milliliter.
Yeah, but I thought it's the average titer for the vinegar, right?
No. Average titer of sodium hydroxide actually.
Oops.
Because you are titrating this acetic acid or vinegar with sodium hydroxide. So average means, you know, right, that 3 times or 4 times you have done, and then you take the average of this 4-time result, and then out of this 4 time you get 15.
Oh,
right.
okay. I get it now.
Yeah.
Thanks, sir.
Okay, all right. So this 15 milliliter you're doing, and then out of the calculating this 15 and 0.2 molar, you get 0.03 number of moles. Since the number of moles should be same for acetic acid and sodium hydroxide, and then the number of moles we get clue for both 003, but I have different volume. It is 20 milliliter, so I just divide by 20 milliliter. I get the concentration of it. I get concentration of it, but this concentration again is for only 20 milliliter liquid. Yeah, 20 milliliter of this. 20 milliliter that is diluted, and then I am making it. I have to multiply with the dilution factor, is 25 times, and then to get the correct concentration. Question number 11. To determine the concentration of ethanoic acid, the same thing, in a sample of vinegar, a 10 milliliter aliquot of the vinegar was made up to 100 milliliter of a volumetric flask, then titrated against 20 milliliter aliquot of sodium hydroxide solution of concentration this. The titration equation of the solution is, of course, the same type of equation, and in this case it was not 15 milliliter, but it was 19.45 milliliter was required. It is last time it was 15 milliliter required. Now it is 19.45 milliliter was required. So 19.45, and then this is the concentration. From there we can find the number of moles of sodium hydroxide, exact number of moles of acetic acid, and this time it is 10 times dilution. It is not 25 times, it is 10 times dilution, and in this way we can find out the same thing, right? Okay, so I'm not going down and going to number 12. The active ingredient. Okay, so for titration, right, we know that titration, last lecture we have seen the titration is you add acid or base to that base or acid to neutralize, right? You acid or base to neutralize another acid or base. Not acid to acid. Of course, if you are taking in the burette acid in the conical flask, it should be base. If you are taking base in the burette, it should be acid in the conical flask. So one acid, one base, one acid, one base. In this way, we do the neutralization reaction, or what is that called? Titration reaction. This is called direct titration. We add acid into base, and when the titration and with the indicator, when the indicator changes color, everything, in that we know that okay, it is titrated, already done, finished. But sometimes this is called straight titration. That is called simple titration. Okay, and sometimes this straight titration, simple titration, does not work. It is not practical in that sense. So what we do is we do back titration. What is the back titration? I'll discuss more about it in next lab demonstration. But in back titration, we add excess amount. Let's say in the burette it is acid. Excess amount of, and in the conical flask it is, let's say it is base. Yeah. So it is acid, this is B is base. we add excess amount of acid in the base, and then after we make sure that all the base has been neutralized by adding excess amount of acid, then the excess so it is not a base anymore, because the excess amount, the extra amount of acid I add into the base, it neutralizes all the base. And guess what? With the excess amount of acid, from base it convert to a bit acidic, because excess amount of acid I added. So what we do? Again, we add some base into it, right? We add some base into it to neutralize that excess amount of acid here. So that is called the back titration. All right, that is called back titration. Okay, so why do we need to use back titration? Because back titration is easier to some cases, like question number 12. The active ingredient of an aspirin tablet is acetyl salicylic acid. The aspirin tablet that many of us have taken many times, and one tablet weighing 5.2 gram. Right, this is the tablet is quite big, like this, bigger than this actually, and the weight 5.2 gram, that is around this, and it was dissolved in 50 milliliter of 5.5 molar sodium hydroxide. You see, 50 milliliter of 0.5 molar sodium hydroxide, it was dissolved at the first place. So what will happen is acetyl salicylic acid. So this salicylic acid, it will react with sodium hydroxide and it will be neutralized. It will be neutralized. But since the base is more, I put more base, then the acid should be required. I have more base now. After being neutralized, I have excess amount of base in the solution. So I have to neutralize that excess amount of base. If I know that how much was the excess amount of base, then from deducting, let's say that this is X amount, this is X amount, right? And the excess amount was Y. So X minus Y will be the required number of moles of sodium hydroxide to neutralize acetyl salicylic acid, right? So this is the thing happening. I put this acetyl salicylic acid in excess amount of sodium hydroxide, and then the sodium hydroxide was later on, excess amount of sodium hydroxide was neutralized. After the reaction, it took 31 milliliter, 31.92 milliliter, 0.289 molar HCl to titrate the excess sodium hydroxide. What is the mass percentage of acetyl salicylic acid in the aspirin tablet? First of all, 50 milliliter of 0.5 molar sodium hydroxide is how many number of moles? What is the number of moles? N equals C into V. So 50 milliliter or 50 over 1000, 0.05 liter times 0.5 moles per liter. All right, so times 0.5, 0.025 number of moles of sodium hydroxide I had used. Number of moles sodium hydroxide I had used, and then I put the tablet inside in that number of moles. After I wait for like 2-3 minutes, I allow the reaction to occur. Then I titrate the sodium hydroxide with HCl. The excess amount of a sodium hydroxide was there. I titrate with HCl. So what will happen is I need HCl is what is that? That's 31 milliliter of HCl, 0.289 molar. So this is the HCl number of mole. Number of mole of HCl is 31.9 times, oh no, 31.9 over 92 over 1000. 31.92 over 1000. So times 0.8289. So 0.00922 number of moles of HCl was required. Now, can you tell me if this much of HCl was required to remove the excess sodium hydroxide, how many moles of sodium hydroxide was there? Exact same thing, right? Sodium hydroxide and HCl is 1:1 reaction. NaOH plus HCl. So this is sodium chloride and H2O. So this is 1:1 reaction, isn't it? This is 1:1 reaction. So if I used 0.00922 moles of HCl, I will have exact same number of moles of sodium hydroxide. Sodium hydroxide. Now the thing is, if I deduct this number of sodium hydroxide, that was the excess amount of sodium hydroxide. But at the beginning, I added 0.025 and I ended up having 0.00922, right? So I will deduct from here 0.00922. All right, so 0.025 minus 0.00922, and I have 0.01515 or 1.8, three significant figure. So 0.0158 moles of sodium hydroxide actually required to react with the salicylic acid. Is this okay so far? Anyone has any question? How do I get the number of moles of sodium salicylate, acetyl salicylic acid? C9H8O4. Number of moles of acetyl salicylic acid is 0.0158 moles. Is this okay? Anybody? Okay, right? No questions so far. Okay, so since the number of moles of sodium, number of, this is not the number of moles sodium hydroxide. I'm telling you one thing and I'm writing another thing. This number of moles of sodium hydroxide was required. Number of moles of sodium hydroxide required was 0.0158 number of moles. All right. Now it is clear that I got number of moles of sodium hydroxide is 0.0158, and now I look at the reaction. It is 1:2 reaction. 1 mole of sodium hydroxide, 2 moles of sodium hydroxide will react with 1 mole of salicylic acid, acetyl salicylic acid. So I will have exactly half of this number of moles of acetyl salicylic acid then, isn't it? Half of it is divided by 2 is 0.00789. 0.00789. Nice number. Number of moles of, okay, divided by 2. Number of moles of acetyl salicylic acid. ASA, acetyl salicylic acid, is this number of moles. All right. Okay. So what is the mass? Since it says that I have to find out the percentage by mass, so what is the mass of acetyl salicylic acid? All right. It is not given here, but we can find it from anywhere. We can find it also from, you know, how do you call it, internet and whatnot. So acetyl salicylic acid, or we can count from here C9H8O4 from here. Altogether it is 12.1 times, I'm just rounding off, times 9 plus 8 hydrogen, so 8.001 or 02 plus 4 oxygen, so 64. 180, around 180. So if I multiply it with 180, I will get the number, mass of sodium acetyl salicylic acid, and the mass is 1.42, around 1.42 something, one something like that. So we have to take it to under the more before we express the final result. This gram is in this tablet, and that whole tablet was 5.82 gram, 5.28 gram, right? 5.28 gram times 100%, and if we find that way, we will find 26%, actually 26.9% of that tablet is actually acetyl salicylic acid. The rest, 73%, is something else, filler, binder, many things. Okay? Is this okay? Anybody has question on this? No? No question. It's good that you understand this. All right. Question number 13, it says that an impure sample of anhydrous sodium carbonate was analyzed as follows. Several 1 gram sample of the impure mixture was weighed out into separate conical flask, and about 20 milliliters of distilled water was added to each. The mixture was stirred, and then 4 drops of an acid-base indicator were added to each of the flask. These were then standardized against hydrochloric acid at concentration of 0.1542 moles per liter molar. According to the reaction, 3 concordant results were obtained to titrate this. The percentage purity of sodium carbonate was what? Now it says that 1 gram sample of impure, 1 gram of sodium carbonate was taken, and it was diluted 4 times. It was tried, 3 times it was tried, and the hydrochloric acid was used to do the reaction, or what do you call it, titration. Hydrochloric acid was used to do the titration, isn't it? So hydrochloric acid, how many milliliter of hydrochloric acid was required for this? Can anybody tell me how many milliliter of hydrochloric acid was required for this? Anybody?
Is it
Um,
0.28?
Let me ask Bilal. Are you there? Bilal, you are not there. Nur Farah, are you there? It doesn't have to be a correct answer. I'm just asking that how do you find? Okay, Bilal is there, but not sure. Nur Farah, are you there? Nur Farah, you are not there. Okay, you good, you're there. So what is the volume of sodium, HCl is required for this question number 13?
Hold on.
Upati, are you there? Upati. Upati not here. Chamod. Chamod, you are not there. Munib.
Yes, sir.
Yeah, you are here. Good. So what is the total volume that will for HCl will be required? Arlene, are you here? Arlene not here today. Okay, so how do you find it? This is the 3 concordant results. Concordant result means we do 4 or 5 testing, and concordant means these 3 were the most closest to each other. 21.25, 21.29, 21.30 milliliter was of HCl was required. All right. So how do you find the average one from these 3? We sum these 3 up, 21.25 plus 21.129 plus 21.30 milliliter, and then we divide by 3, the average, the arithmetic average. It's a simple average, it says. So in this way, we will find that the average is 21.28. The 21 point, oh, not here. So it is 21.28 milliliter. Okay. It's not 22.5, not 21.28, not 0.30, but average is 21.28, right? So if we have 5 result, like another 2 result, 21.27, 21.32, I would have to take all 5 and then divide by 5, so that I will get a arithmetic or simple average. So this is how we find the average. Now, in 21.28 milliliter of HCl, right? And the HCl concentration is 0.1542 milliliter. It's simple thing, so that I understand what is that concentration. Number of moles in HCl, 0.1542. 1542 times this milliliter will be converted to liter, so 21.28 over 1000, so it is 0.00328. 00328 number of moles, right? This one is 8. 0.00328 number of moles. And then again, this is 1:2 reaction. 1:2 reaction. So if 2 moles of HCl, 1 mole of sodium carbonate will be there. So 0.00328 mole of HCl, that means half of 0.00328. So divided by 2, it will be 0.0016. 0.0016 number of moles of sodium carbonate is there. The percentage by purity it is asking, and this, since it is 0.0016, we just multiply with the molecular mass so that I will get the molecular weight of this, and the molecular mass is 106, right? 106, so that we find the value. That value we have to divide by 1 gram. All right, 1 gram times 100%, so that we will find the concentration, and then it's showing is still 7.39 or 7.39, not 9, 7.39 is the correct answer. Question number 14. Some household cloudy ammonia in which the active ingredient is ammonia is to be used. This is a drain cleaner, actually we use at home sometimes as drain cleaner, is to be used for its ammonia content by direct volumetric titration. It is not a back titration, it is direct volumetric analysis. Using a standard solution of HCl of molarity 0.101 mole per liter, the level of the ammonia states that the concentration of ammonia present is 5% of the equation for the reaction. So that 20 milliliter aliquot of the ammonia solution will require a titer of the acid about 20 milliliter. By what factor must the cloudy ammonia be diluted for this analysis? It says that the ammonia, the table of content for ammonia says that it's 5% weight by volume, and if we have to dilute, 20 milliliter aliquot of ammonia solution will require titer of the acid of 20 milliliter. By what factor? If it's a 1:1 reaction, if you have to use the same volume, so far we have seen that volume can be different, but the number of moles is same. So if I use the same volume, X milliliter of HCl, if I want to use X milliliter use HCl and X milliliter of ammonia, and both of them will be neutralized, to what extent should I dilute this ammonia from this 5% of ammonia? To what extent should I dilute this? Now n equals into V once again, and from the HCl it is 0.101, right? It's 101 we see, so that we can. So it's 101. Where do I write it? This is 101. I'm not going to write a lot. Time is not limited. So 101, and the volume of 20 milliliter, right? It's 20 milliliter. Okay, it's 20 milliliter. So times 0.02 liter. And then we will find the number of moles. Once again, we will find the number of moles for this. And again, what I said that it's 1:1 reaction. So it will have the same number of moles. The ammonia will have the same number of moles. And since we are using 20 milliliter also, 20 milliliter of ammonia also we will be using. So in 20 milliliter, this number of moles should be there. 20 milliliter, this number of mole should be there, right? So What's the number of moles? It is 0.002 number of moles of HCl and ammonia. Okay. Oh. So the number of moles is 0.002 and number of moles of the ammonia will have the 0.002 number of moles, right? Number of moles, just like the HCl, 2 moles, because it's 1:1 reaction. Only the thing is, it has to be in 20 milliliter, in 20 milliliter of this solution, and both of them are 20. So if this is the 0.002 moles of ammonia, what is the mass of it? Because it says that what is the percentage by mass, right? By what factor should be diluted? So the mass of this is 17. From there we find that it is 0.034 actually. 0.34 mass of ammonia. So ammonia NH3 is 0.34. 3434. This is the mass. The mass of ammonia is 0.3434. Now it says that if it has to be 5% weight by volume, that means 5 weight by volume, right? Weight by volume. So 5 gram in 100 milliliter. That is the percentage in 100%, right? We know that. So it has to be 5 gram in 100 milliliter for this ammonia, then only it will be 5%. So if 0.3434 milliliter of ammonia in 20 milliliter of diluted solution, right? We can find out that per 100 gram, how many times has been diluted. So it is 0.3434 times 5 gram, because 5 gram should be in 100 milliliter, so that it will be 5 weight by volume. That means 5 gram in 100 volume milliliter. Then it will produce 5 weight by volume. So 5 gram in 3434 mass into 5 gram, and this is 0.17, is it? 0.1717. 17 gram. All right. So out of 5 gram, this 0.1717 gram means actually what? Our target was 5%. Our target was to find out what is the dilution has been done, and in that case, I have only 0.1717 gram in my solution of this 20 milliliter, 0.2 molar. Actually, I took it from 5.8%. So 5 over 0.1717. In another way, you can do it, but this is the fastest and shortest way. So it is 29, around 29 times, 29 point sometimes. So this is 29 times diluted. This solution was 29 times diluted. Okay. Anybody has question on this?
Sir?
Yeah?
0.002 moles times 17 is supposed to be 0.034, right?
Should be.
Is it?
Is it 0.002? Let me check the first one. 0.101. 0.101, and it is in 20 milliliter. So 0.02. 0.002. Yeah, 0.002 and times 17. So yeah, 0.034034. Sorry, typing mistake. 3434. All right. 0.3434. Yes, so it will be 0.3434 as well. And then if I multiply by 5, yeah, so only then it becomes 0.17, 0.1717. Thank you. Anyone has any question with this? Okay, so everybody understand, that's good. Question number 15 says that the active ingredient of a certain toilet cleaner that claims to remove lime scale and rust in hydrochloric acid of approximate concentration 3 mole per liter. To analyze this toilet cleaner, a quality control chemist first deliver 10 milliliter aliquot of the toilet cleaner into 250 milliliter flask. So that 210 milliliter was already diluted 250 milliliter. That means 25 times dilution will be done. Then made up the dilution, she then titrated 20 milliliter from here, exactly like 11, question number 11 almost. So 20 milliliter aliquot from this diluted solution was taken standard soda and against standard sodium hydroxide solution of concentration 0.1044 mole per liter. The expected titer would be approximately what? So 20 milliliter time number of moles of sodium hydroxide. 20 milliliter means 0.02 liter times this one. So we find the number of moles of sodium hydroxide. Number of moles of sodium hydroxide. It's easy actually. The expected titer would be approximately, how many milliliter of the titer should we be needed? So this number of moles of sodium hydroxide and the same number of moles will be there as well. Same number of moles of HCl will be there, and okay. So is asking us the volume of it. So number of moles we found, and then if we divide by the concentration, right? If we divide by the concentration, we will find the number volume. The concentration was 0.104. So the concentration is 104. Wait a bit, I'm reading. 3 mole per liter. Concentration was 3 mole per liter. To analyze this toilet cleaner, 250 milliliter volume flask and 20 milliliter aliquot of this solution was against titrated sodium hydroxide solution 0.1044 milliliter of solution. So it is 0.3 molar. Number of moles of HCl should be 3 mole per liter. So 3 moles per liter, that is moles per liter, and then 10 milliliter of this 3 mole per liter is we can find the concentration of this. A quality control chemist first delivered 10 milliliter liquid of the toilet cleaner into 250 milliliter, then made up the diluted solution. She then titrated 20 milliliter liquid of the diluted solution against standard sodium hydroxide solution of concentration of 0.1044 moles. Okay. So this 3 milliliter, it's so tiring to read all the big long details. Okay. 3 moles per liter, and if I take 10 milliliter of this 3 moles per liter, how many number of moles will be there? Right, 3 moles per liter, and in 10 milliliter is 0.01 liter. So I have 3 times 0.03 number of moles. Okay, 0.03 number of moles. Although it was diluted to 250 milliliter, yeah. So this is diluted to 150 or 25 times dilution. So it will be 0.03 over 25 is 0.0012. 0.0012 number of moles is expected to be there. 0.0012 number of moles is expected to be there. And this 0.12 number of moles, out of this I took 20 milliliter aliquot of this solution, and then concentration was used to this 1:1 reaction again, so the number of moles will be the same, right? So we can just use C1, V1, C2, V2 going all through this way. No, not to go all through this way. We can just use 3 molar of 0.01 molar, all right? 0.01 molar of C1 or N1, V1, whatever way you know it. So N1, V1, N2, V2 in this way. We will find the C2, that is the concentration, or N2 actually in this case, will be 0.12 molar. If we plug in the values of V equal to 20 milliliter and the 250 milliliter for concentration 2 and 3 molar for, okay, 3 molar, and this is, where is that? 250 milliliter is there, and 20 milliliter for here, right? 20 somewhere, yeah, 20 milliliter is here. So N2 we need to find out, and V2 is 250 milliliter. So if we plug in this value all together, we will find the number of moles for this HCl in the diluted solution is 0.12 molar. So this 0.12 molar in the number of moles for 0.12 molar solution in 0.20 milliliter of the solution will be 0.02 number of moles, 0.0024 moles in 20 milliliter, right? So from there we can find the same number of moles for sodium hydroxide, and it will be divided by N over V to get the concentration. Sorry, V is N over C. So it is 0.1044. So from there I will find it is 23 milliliter required. Okay, so this is how we can do it. My mind becomes foggy because of,
Sir,
yeah,
I don't understand the whole question.
okay. Give me 2 minutes, yeah? I bring some tea. Ugh. Okay. Let me delete it first. Or not delete, erase first, then we talk again. Go faster. Okay, the question is saying that we have a toilet cleaner, and the toilet cleaner, main ingredient in the toilet cleaner is the HCl, hydrochloric acid, that is the HCl. Okay, hydrochloric acid, HCl. And approximately the concentration of the HCl is, let's say that concentration is N1 or C1, which one is, good for you. Let's say concentration. So C is 3 molar, 3 mole per liter of the HCl is 3 molar. I have a toilet cleaner in my house and it is 3 mole per liter HCl in that toilet cleaner actually. I want to analyze these three by I want to go for titration to do with sodium hydroxide. And I know that is 1:1 reaction, sodium hydroxide and HCl will react. So before I do the titration, since it says that approximately 3 mole per liter, approximately how many milliliter of sodium hydroxide I will require before I do the titration, I can calculate. How do I calculate? This is the thing. To analyze the toilet cleaner, a quality control chemist first deliver 10 milliliter liquid of the toilet cleaner into 250 milliliter volumetric flask, then made up the diluted solution. So 10 milliliter of this 3 molar was diluted to 250 milliliter. So it was 25 times diluted already. Times. Right? 25 times it was diluted. And then she titrated 20 milliliter from that diluted, just like the previous that I draw, right? It was the volumetric flask. It is 250 milliliter, and I add 10 milliliter, another 250 milliliter water, and then I took 20 milliliter from here for analyzing further analysis. So now I understand that all 10 milliliter, whatever the number of moles was in 10 milliliter is in the 250 milliliter. Number of moles. Number of moles is the same, but the concentration is not same. And then from that 250 milliliter diluted thing, I took out 20 milliliter from this. All right. So in that 20 milliliter, there is not the same number of moles as in 10 milliliter. Right? Of course, it's different. So how do I know what will be the concentration after I have diluted it to 250 milliliter? What will be the concentration? I can find out the concentration. C1V1 is equal to C2V2. Right. So C1, I already, this one is C1, 3 mole per liter. And V1 is the volume that I have in the 10 milliliter of the solution that I took. So C1 is 3 mole per liter, and V1 is 10 milliliter, that means 0.01 liter. C2, I do not know what will be the concentration after it becomes diluted to 250 milliliter. So I just leave it like that. And V2 is the volume of 250 milliliter, all in liter. So it is 0.25 liter. From here, I see that C2 is the concentration after it becomes diluted. The concentration is 0.12 molar. Okay, 0.12 molar concentration. Molar means mole per liter, right? Molar means mole per liter. The concentration is 0.12 molar. Now, if it is 0.12 molar, how the 20 milliliter that I have taken out of this 250 milliliter. So this 250 milliliter has the same molarity, which is 0.12 molar, right? It is 0.12 molar. The molarity is 0.12 in the whole 250 milliliter. So the 200, I mean, out of this 250 milliliter, which is 0.12 molar, I just took 20 milliliter of the solution. I took 20 milliliter solution. So 20 milliliter solution means I am taking 0.12 molar of 20 milliliter solution. So if 20 milliliter means 0.2 liter, if I multiply, I will know the number of moles here in 20 milliliter, which is 0.0024. 24 moles. So 0.0024 moles of HCl, I will have to titrate it with sodium hydroxide with a concentration of this number of moles per liter, actually, moles per concentration. So this is a N, right? This is N, and this is concentration, that means is C. So if I want to know V, because N equals C into V, I will just divide N over C. That means I will divide by 0.1044. Right, 1044. So by this way, I will find the volume, required volume. Yeah, I'll know the required volume will be 23 milliliter, around 23 milliliter, if not exactly 23 milliliter, around 23 milliliter. All right. So is this okay now?
Yes.
All right. And for all the past exam question is, some of them are balancing the equation that we have done it. Some of this descriptive question, you have to write the descriptive question and go and try at home. And if you have any question out of this, let me know so that I can discuss. Okay. So this is our time until today, and time is up. So I'll see you next Monday.